Hey everybody, I want to go over finding a summation without necessarily adding up all the terms if it is an arithmetic sequence. Okay, so what I did here was I listed an arithmetic sequence. 1, 2, 3, 4, 5, 6, 7, 8. Only 8 terms in this sequence. Obviously, a much bigger one, it would be impossible to add them all up. So what I'd like to do is just do one that's small here just to show you a little trick that works. One thing you notice about arithmetic, and this is arithmetic because it goes up by 2 each time, is if you list a bunch of terms and you add the first and the last, the second and the second to the last, the third and the third to the last, and the fourth and the fourth to the last, you will always get the same number if it's arithmetic. So if you look here, this is 18, 18, 18, 18. There are 8 numbers here, and you have 4 groups of 18, which adds to 72. Little faster than adding them all up. Obviously, if there were 50 numbers here, it would be super fast to be able to do it this way instead of adding them all up. So here is how you do it. You add the first term and the last term. So if I want to find the sum of the first 8 numbers, I would add the first term and the 8th term. And if I'm adding 8 numbers here, then there are half as many groups of that total. So my first term was a 2. My last term was a 16. So I have 8 over 2, 2 plus 16. So first term plus last term, you get that 18. How many groups are there? If there's 8 terms, there's half as many. That's why it is times 4. Now, here's the official formula for that. The sum of n terms of an arithmetic sequence is always half the number of terms, like we had 8, so it was 4, and you add the first term and the last term that you want to add up. So if it's s of 8, it's a sub 8. If it's s sub 100, this would be a sub 100. Now it's a little easy to see when there's an even number, but let's try this one. So now it's still arithmetic, going up by the same number we had before, 2. I just adjusted it slightly. But now I'm only adding up 7. You still are going to do the same thing. I just want to show you how it would work. You add the first and the last this time. 2 plus 14, you get 16. This is 16. And this is 16. But you have this random one, which is exactly half of our total that we get when we add the first and the last. So let's use the formula here. So if we're finding the sum of the first 7 numbers, 7 over 2, we have 3.5 groups of 16. 16, 16, 16, and 8 is half of that. My first number is a 2. My last number is a 14. So I have 3.5 groups of 16. That is to show you where the formula comes from. So if you didn't write any notes on this, that is okay. Now I'm going to show you this guy. This is the formula that I just showed you for the sum of an arithmetic series when you don't want to add them all up. However, this one over here does the exact same thing. And where this one comes from is if you take the original and you replace a sub n with the formula that you already learned, which was a sub 1 plus d n minus 1. We learned that's what a sub n always equals. You'll see we have 2 a sub 1s. I'm going to use a bracket because that's awfully big there. Plus d n minus 1. And that is another formula. So the only thing different about this one is that they replace a sub n with the formula we already know. So you have 2 formulas that I'd like you to fill in on your formula sheet for summation of an arithmetic sequence, which makes it a series when we're summing it. Now I want to show you 2 things. This question is exactly the same question, even though they look crazy different. This one shows the sequence. The first term is a 1, going up by 2, and I want to find the sum of the first 10 numbers. This one, sigma means sum. I'm still finding the sum of the first 10 numbers. of the sequence defined by this formula. If I plug in a 1, 2 times 1 minus 1 is 1. If I plug in a 2, 2 times 2 is 4. 4 minus 1 is 3. This one just has the sequence written out, where this one gives you the formula for each one. Okay, so let's try it. If I want to find the sum of the first 10 numbers, let's use this second formula. Sum of the first 10. I need 10 numbers I'm summing, so it's 10 over 2. 2 times my first term was a 1, plus my D value. What is it going up by? It's going up by 2, and 10 is the N value. Feel free to go to your calculator or do this one in your head. 10 divided by 2 is 5. 2 times 1 is 2. This is 2 times 9, which is 18. So you have 5 times 20, which is 100. Now, let's use the first one, which I'll be honest with you, I like a little bit better. The first formula, sum of the first 10 numbers, it says n over 2. So I'm adding 10 terms, so it's 10 over 2. First term, I like this because I just plug this number in to get the first term. 2 times 1 minus 1 is 1. And I can find the last term really easily by plugging in that top number. 2 times 10 is 20. 20 minus 1 is 19. 10 divided by 2 is 5. And 1 plus 19 is 20. So you will get the 100. So let's just recap. Same question, written 2 different ways. You can use either formula that you like. I used the second formula on this one, and I used the first formula on this one. Either way is fine. Feel free to use whichever one you like. Okay, now let's go into 2 examples here. Number 1, find the 10th partial sum. I need S of 10 of the arithmetic sequence. So I wrote it both ways here. I started writing out the terms and said you need to find S of 10, or I wrote it in the fancy summation notation. It says use both formulas. So let's do it up here. Both formulas are S sub n equals n over 2, a sub 1 plus a sub n. And then the other one, S sub n equals n over 2, 2a sub 1 plus d, and minus 1. Okay, so this guy right here, I'm looking right here. I'm adding 10 numbers up. 10 over 2, so plug 10 in for n. My first term, well, I see it's a 5 here, or I could plug it in. 3 times 1 is 3, 3 plus 2 is 5. Why I like this way of writing it, I don't have the 10th term here, or unless I want to write them all out. I like because I can plug the 10 in. 3 times 10 is 30. 30 plus 2 is 32. So now 10 divided by 2 is 5. 5 times 37 is 185. Okay, or feel free to do it using this form. So I'm finding the sum of the first 10 numbers. It's 10 numbers again. 2 times my first number I can get here, or I can plug in the 1. So 2 times 5. What is it going up by? I look at this sequence. It's going up by 3. Arithmetic term formulas always kind of look like Algebra 1, no exponents, and the number in front is always your difference, your common difference is going up by 3. So you can get it from here, or you can see 3, and then 10 minus 1. A little bit longer formula. So you have 5, and in parentheses, 2 times 5 is 10, plus 3 times 9 is 27. So now you'll have 5 times 37, which is again 185. So whichever way you feel comfortable, please pick the formula that you like. All right, last one. Math prizes. I plan on giving a $5 math bonus to the highest score on the first test. So immediately if I'm reading this word problem, I'm going to write a sub 1 is 5. If I increase the bonus by 350 each time, so I'm going to go up, my common difference is 350. what will the 11th prize amount be? So I need a specific prize amount. So I'm going to go back to my specific term formula. A sub 1 is 5. What did we say it's going up by? 350. Which term do I want? I want the 11th term. 11 minus 1 is 10. 10 times 350 is 35. 5 plus 35 is $40. So that's my last term. I'm giving 11 tests. Next part says, and how much will I have given out altogether? Now, this is a personal preference. If I clearly have the first and the last, I like to use the shorter formula. Doesn't mean you can't use this one. I'm going to show the shorter one. So I'm finding the sum of the 11 tests, 11 over 2, and the first is a 5. My last prize I'm giving is 40. So I would go to my calculator. 11 divided by 2 is 5.5. So I will have 5.5 groups of 40. That's $220. So Mrs. Hoven would need to have $220 in her desk to start giving out that cash. So again, this is arithmetic summation. Use whichever formula you want, unless you're looking at it and they're not asking you for the sum at first, they're asking you for a term, then use the old formula. Okay, hope that helps.